Hi, this is Tom, and welcome to the second video for lesson 36, the coefficient of determination. So in the last video, we made this table here, and we ended with this quandary. The quandary was, how come all of our spaces are zero, and, well, we can't get anything from zero. So what we're going to do is we're going to make some corrections. And it's the same correction that we made when we first learned about calculating the variance of a data set. And that was what we did is we squared these residuals or deviations. And those words are being used interchangeably here. So let's do that. We're going to take the sum. We'll keep our colors consistent here. So let's work here first with our total variation. And so all of our t's, this is their total deviation, I should say. So we're going to take the sum of the t's squared. So that means I'm going to take the negative 2/3 squared plus, I'm going to have the 1/3 squared plus 1/3 squared. So when I do that, I get 4/9 plus a ninth plus a ninth. That's 4/5. That's 6/9, which is the same as 2/3. And we're going to give this a name. We're going to call this the total variation of the y. So we're going to write it like this, and that stands for total variation of the y's. Total variation of y. Now, the word variation and variance are very closely related. If I wanted to find the variance of the y's, I would have done this. I would have said, the variance of the y's would equal, well, I would have gone through this exact same process. I would have squared all those, added them up, and I would have had 2/3. And then I would have divided that by the number of data. This is what we call variance. And that's because the difference is just the fact that we divide by number of data. And for samples, we would divide by n minus 1. So it really was created an average, and when you do that, it's variance. When you don't divide, it's called variation. So right now we've found our total variation of the y's. Let's continue with this, and now let's see, the next one we have is D. That's our explained deviations. So we're going to find the sum of our explained deviations squared. So that means I'm going to take my minus 1/2 and square it, plus 0 and square it, plus 1/2 and square it. And let's see, this becomes 1/4 plus 0 plus 1/4, that's 2/4, that's 1/2. And we're going to call this the variation of the y primes, because that was the distance of the y primes from the mean. And then we'll calculate one more. We'll also calculate the errors, and so we're going to just call this the total variation of the errors. We're going to call it E. And we'll do this as the sum of the e's squared. Well, I have minus 1/6 squared plus 1/3 squared plus negative 1/6 squared. So this is going to be 1/36 plus 1/9 plus 1/36. Let's see, you need a common denominator for the 9 of 36. So this is going to be a 1 plus 4 is 5 plus 1 more 6, which is going to give me 6/36, which is 1/6. Now, why did we do all this work? And let's put this together. And here's the question. The question is this. the question is how much of the variation, oops, I wrote the twice. It's a terrible habit I have. The question is how much, let's do this better. Here we go. How much of the variation in y is explained by the variation in x? And in other words, if we know our x's and we create a model, well, there's imperfection in our model. And the imperfection are all the little errors. That's what we missed. That's where we were slightly off. And all of the d's, well, that's where we got it right. And so the question is what percentage of the irregularities that we're seeing between the actual and the predicted is a result of, or the success of, our model? What percent is that? So when you say how much, or you could also think of how much as a percent. And here's what it is. And that is the total variation in y. Well, how much of that is explained? Well, that's the variation of y prime. So let's see what this gives us. This would give us the variation of y prime was the orange up above, and that was 1/2. And the total variation of y was our pink up here. That's the 2/3. So we're using this 2/3 and this 1/2. So divided by 2/3. Well, division of fractions isn't so bad. You take the first fraction, 1/2, and we divide it by the second fraction of 2/3, which means you flip and multiply. So the 1/2 stays the same, the division becomes multiplication, and then we write the reciprocal of the 2/3, which is 3/2. So 1 times 3 is 3, and 2 times 2 is 4. Well, 3/4, if you put it in your calculator, is 0.75, which is the same as 75%. And so we would say that 75% of the variation of y is explained by the variation of x. And also, if you think about this, so this was actually a really good model. We said, well, and actually we're going to stop there, and then we're going to look at one other way that we can find this number. Oh, but before I leave, this number, this ratio, which works out to be this percentage, is called, it's called the coefficient of determination. And it's denoted by the letter r squared. All right, in the next video, we're going to find one other way that you could calculate the coefficient of determination. See you in the next video, and thanks for watching.